What if I told you there's a world hidden beneath our feet, hotter than the surface of the sun, where pressures could crush a submarine like a tin can? We're not talking about science fiction or some distant planet. This is real, and it's right here on Earth, locked inside the deepest volcano known to humanity. Imagine a place so extreme, so untouched, that it holds secrets capable of rewriting what we think we know about our planet. Are you ready to dive into this geological enigma and uncover what's truly inside? Picture this: a journey into a place where the air burns, the walls pulse with molten rock, and the pressure is so intense it could flatten steel. This isn't just any volcano, it's the Earth's deepest, a monstrous chasm that plunges far beyond the reach of sunlight, human exploration, or even our wildest imaginations. We were not talking about your average backyard volcano with a fiery glow and a bit of ash. This is a beast, a geological marvel that could be a gateway to the Earth's core, hiding mysteries that have been locked away for billions of years. But what exactly is the deepest volcano? To answer that, we need to clarify what deepest means. Volcanoes don't just sit on the surface like a pimple on the Earth's crust. They were connected to vast systems of magma chambers, conduits, and tectonic forces that stretch deep into the planet. So what would it take to explore this fiery abyss? And what could we find in a place so extreme it defies human survival? Let's embark on this journey together, peeling back the layers of rock, heat, and mystery to reveal what lies within. Before we plunge into the depths, let's break down what a volcano actually is. At its core, a volcano is a rupture in the Earth's crust, where molten rock, ash, and gases escape from below. But the real magic happens far beneath the surface. A typical volcano has a magma chamber, a reservoir of molten rock that feeds eruptions. These chambers can sit a few miles underground, but in the case of the deepest volcanoes, their roots may extend much farther, tapping into the mantle, the semi-fluid layer that makes up most of the Earth's volume. Kīlauea, for example, is part of the Hawaiian hotspot, a plume of molten rock rising from deep within the mantle. Seismic studies suggest its magma source could originate 50, 60 miles, 80, 100 kilometers down, where the Earth's interior is a cauldron of liquid rock and intense pressure. This makes Kīlauea a prime candidate for our journey, as its plumbing system reaches depths few other volcanoes can match. But it's not just about depth. Volcanoes like Kīlauea are dynamic systems, constantly shifting. Magma moves through conduits, fractures in the crust that act like highways for molten rock. These conduits can stretch deep, connecting the surface to reservoirs far below. As we descend, we'd encounter a labyrinth of molten channels, solidifying lava, and pockets of superheated gas. It's a world that's alive, unpredictable, and utterly alien. Let's be real. Humans can't just stroll into a volcano. The conditions are beyond brutal. So, how do we explore this? Forget about physical travel for now. No suit or vehicle could withstand those conditions. Instead, scientists rely on indirect methods: seismic imaging, drilling, and robotic probes. Seismic waves generated by earthquakes or controlled explosions can map the subsurface, revealing magma chambers and conduits. Deep drilling projects, like the Kola super-deep borehole in Russia, which reached 7.5 miles or 12 kilometers, show how tough it is to penetrate even the crust. To go deeper, we'd need futuristic tech. Think diamond-coated probes or laser-based boring systems that could withstand molten rock and crushing pressures. For our imaginary journey, let's assume we've got a sci-fi-worthy probe, built to survive the heat and pressure. As we send it into Kīlauea's depths, what do we see? Our probe begins its descent through the volcano's throat, the main vent where lava erupts. The walls are jagged, coated with cooled lava and studded with crystals formed as magma solidifies. The air, or rather the gas, is a toxic brew of sulfur dioxide, carbon dioxide, and water vapor, glowing faintly from the heat. As we drop deeper, the vent narrows into a network of conduits, some as thin as a straw, others wide enough to swallow a house. At a few miles down, we hit the magma chamber. This isn't a neat pool of lava like in the movies. It's a chaotic sponge of molten rock, crystals, and gas bubbles. The magma here is a mix of silicate minerals, superheated to a syrupy consistency. But we're not stopping here. The deepest volcanoes, like Kīlauea, have roots that stretch into the upper mantle. At 30-50 miles down, we enter a realm where the crust gives way to denser, hotter rock. The mantle isn't fully molten, it's more like a plastic flowing solid, but pockets of magma pool here, feeding the volcano above. The probe detects exotic minerals like olivine and pyroxene, forged under pressures so extreme they can't exist on the surface. These minerals hold clues to the Earth's formation, trapping ancient gases and isotopes from billions of years ago. So, what's down there that's so mind-blowing? For starters, the deep volcano is a time capsule. The rocks and gases trapped in the mantle carry signatures of the Earth's infancy, when our planet was a molten ball of chaos. By studying these materials, scientists could unlock secrets about how the Earth formed, how its core and mantle interact, and even how life itself might have emerged. Some theories suggest that deep volcanic systems could have been cradles for early microbial life, with heat and chemicals providing the energy for primitive organisms. Then there's the potential for new materials. The extreme conditions in the mantle create minerals and compounds we can't replicate on the surface. Diamonds, for instance, form under similar pressures, and while Kīlauea isn't a diamond factory, its depths could hold other rare crystals with unique properties. Think super-hard materials or superconductors that could revolutionize technology. But the real game changer is what these depths tell us about Earth's future. Deep volcanic systems are tied to plate tectonics, the engine that drives earthquakes, mountain building, and climate shifts. Understanding how magma moves from the mantle to the surface could help us predict eruptions with pinpoint accuracy, saving lives and economies. It could also reveal how volcanoes influence the planet's carbon cycle, which regulates climate over millions of years. Here's the catch. We're nowhere near ready to explore these depths directly. Current technology can barely scratch the crust. The deepest we've drilled is about 7.5 miles, and even that took years and millions of dollars. To reach the mantle, we'd need breakthroughs in materials science, robotics, and energy systems. Our sci-fi probe would need to be made of something like carbon nanotubes or advanced ceramics, powered by a compact nuclear reactor or some yet-to-be-invented energy source. It would also need sensors capable of analyzing molten rock in real time, sending data back through miles of solid rock. And then there's the ethical question. Should we even mess with these depths? Drilling or probing could destabilize volcanic systems, triggering eruptions or releasing trapped gases. The mantle is a high-stakes environment. One wrong move, and we could unleash forces we don't fully understand. So, why care about the deepest volcano? Because it's more than just a hole in the ground. It's a window into the Earth's soul, a place where we can touch the raw forces that shaped our world. The secret's locked in its depths, ancient minerals, clues to life's origins, keys to predicting disasters, could transform science and society. And let's not forget the sheer awe of it. There's something humbling about standing at the edge of a volcano, knowing it's connected to a world so vast and powerful, it makes us feel like specks in the universe. As our imaginary probe returns to the surface, battered but intact, we're left with more questions than answers. What else is down there? Could there be life forms we've never imagined, thriving in the heat and pressure? Could the mantle hold the key to clean energy or new technologies? The deepest volcano isn't just a challenge, it's a call to adventure, a reminder that our planet is still full of mysteries waiting to be explored. So next time you hear about a volcano erupting, don't just think of lava and ash. Think of the hidden world beneath, a place of fire and pressure, secrets and possibilities. Are you ready to keep pushing the boundaries of what's possible? Because the Earth's deepest volcano is waiting, and it's got stories to tell.